Welcome to The Explainer. Today, we are diving headfirst into the world of artificial intelligence. And look, I know it can seem incredibly complex, full of jargon. So our goal is simple. We're going to demystify it all with a clear, straightforward map of 20 key terms you really need to know. So let's just start with the one question that seems to trip almost everyone up, right? By the end of this short explainer, I promise, you won't just know the answer to this, you'll have a solid framework to understand pretty much the entire field. Here's our roadmap for today. It's a 5-step journey. We'll kick things off with the core concepts, then we'll look at how these machines actually learn. After that, we'll explore the jobs we give them, see how they're built on the assembly line, and finally, cross the finish line to see how we grade their work. All right, first up, the core concepts. This is where we build our foundation from the ground up and answer that big question we started with. What is the real difference between all these buzzwords? Okay, so at the very, very top of everything, we have artificial intelligence, or AI. You should think of this as the biggest possible umbrella, the ultimate goal, just making computers act smart like we do. Like a receptionist who uses their own judgment to figure out who to route a call to. Any system that makes a choice based on its situation, well, that falls under this massive umbrella of AI. Now, here's where it gets interesting. Inside that giant AI umbrella, you find machine learning, or ML. This isn't a separate thing. It's a specific way to achieve AI. Instead of a human programmer trying to write a million if-then rules for every possibility, we just let the computer learn the patterns for itself. It's exactly like how a kid learns what a dog is, not by reading a definition, but by seeing tons and tons of different dogs. And if we go one level deeper still, we find deep learning. This is a really powerful, specialized type of machine learning. It uses these complex structures called neural networks, which are actually inspired by our own brains, to learn incredibly detailed patterns. This is the magic behind how your phone instantly recognizes your face. It doesn't follow a simple checklist, it just knows. So if we're saying the machine is learning from data, what does that actually look like? How do you teach it? Well, it turns out there are 3 main styles of learning. So the 2 most common ways are supervised and unsupervised learning. Think of supervised learning as studying with an answer key. We give the machine data that's already labeled, like a million pictures of cats that are all labeled cat, and it learns by checking its own answers and fixing its mistakes. Unsupervised learning? Well, it's the exact opposite. We just give it a mountain of unlabeled data and say, go find the interesting patterns in here. It's like sorting groceries into piles without anyone telling you what the categories should be. The 3rd style is reinforcement learning, and this one is all about trial and error. The machine, which we call an agent, tries taking actions in an environment. We give it a reward, a digital treat for a good action, and a penalty for a bad one. And over millions and millions of tries, it learns the strategy that gets it the most rewards. It's just like training a dog. Okay, so now we know the core ideas and the different ways that machines can learn. But what specific jobs can we actually hire an AI to do? Let's meet the AI task force. 2 of the most fundamental jobs are classification and regression. Classification is all about putting things into buckets. Is this email spam or not spam? Is this a cat or a dog? Regression, on the other hand, is about predicting a specific number. What's the temperature going to be tomorrow? What's the price of this house going to be? One sorts, the other predicts a value. Hey, remember unsupervised learning, the one with no answer key? Well, its main job is something called clustering. This is where the AI automatically finds hidden groups in your data. It's what companies use to sort customers into different segments, just by finding which data points are most similar to each other. Next up, we have a huge one, natural language processing, or NLP. This is the entire field that's dedicated to teaching machines how to understand, interpret, and even generate human language. Seriously, every time you talk to a smart assistant or use an online translator, you are using NLP. And everything that NLP does for text, well, computer vision does for images and video. This is the task of making machines see and understand the visual world. It's about detecting patterns in pixels to recognize everything from a stop sign for a self-driving car to a specific person in a photo. So, we have text, we have pixels, and the 3rd domain here is speech and audio AI. This is the field that handles sound waves. It's what allows a machine to listen to your voice and turn it into a command. Or, on the flip side, to generate a totally realistic-sounding voice for something like an audiobook. And finally, there's a task that you interact with probably every single day, recommendation systems. This is the AI that predicts what movie you'll want to binge next, what song to add to your workout playlist, or what product to buy, all by learning from what you've done in the past. So we've seen all these incredible jobs that AI can do. But that begs a huge question. How do you actually build one of these things? This brings us to part 4, the assembly line. And the very first and maybe most important stop is data pre-processing. You have to understand, real-world data is always messy. You have to clean it all up. It's like washing and chopping your vegetables before you can even dream about cooking. Okay, once the data is clean, we move on to feature engineering. This is a surprisingly creative step where you turn that raw data into useful signals or features for the model. For instance, instead of just giving the model a date, you might create new features like day of the week or is it a holiday? You're just giving the model better clues to learn from. Now we get to the main event, model training. This is that learning part we talked about earlier. The model makes a prediction, checks to see if it was right, adjusts its internal settings just a tiny bit, and then repeats this whole process millions of times. It's slowly getting better and better, just like practicing basketball shots to perfect your aim. And finally, deployment. Because let's be honest, a model that only works on a data scientist's laptop isn't very useful, is it? Deployment is the whole engineering process of taking that trained model and putting it into a real-world application so it can serve predictions to actual users, complete with all the monitoring and maintenance it needs. Which brings us to our last section, the finish line. Our model is built, it's out in the world, but the job isn't quite done. Now we have to actually grade its performance and watch out for a really critical pitfall. See, the biggest challenge in training is finding the perfect balance. On one hand, you have overfitting. This is when your model is like a student who just memorized the answers to the practice test. It gets a perfect score on stuff it's already seen, but completely fails on any new questions. The opposite is underfitting. That's like the student who didn't study at all and can't even answer the basic questions. The goal is to land right in that sweet spot in the middle. So how do we know if we've actually found that balance? We use evaluation metrics. These are basically the report card, the scores we use to grade our model. And depending on the job, we might care more about accuracy or speed or maybe fairness. These metrics are how we compare the model's predictions to the real results to see how well it's actually doing. And that brings us to our final term, and this one really represents the exciting future of the entire field, generative AI. See, until pretty recently, most AI was about understanding or predicting things. Generative AI is completely different. It actually creates brand new original content, from text and images to computer code and music, all based on the patterns it's learned from the data it was trained on. Which leaves us with one last, really fascinating question. For decades, AI has been about understanding the world. Now it can actually add to it. That shift from pure analysis to genuine creation is a monumental leap. So what comes next? Now that AI can create, what are we going to build with it? That's the question that's going to define the next chapter of technology.